Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to power systems engineering. In the previous video we discussed about polyphase systems and we arrived at the conclusion that for AC power systems mostly the three-phase system is commonly used. In this video we are going to discuss about the various ways of interconnection of the three phases. So a quick review again. The three-phase four-wire system which is commonly used, it consists of three voltages, each having same magnitude and frequency but different phases. Okay, the phase angle difference with respect to them, that is different. Mostly it is 120-degree phase difference leading and lagging with respect to each other. So magnitude and frequency of the voltage is same but phase angle is different with 120-degree leading or lagging with respect to a reference. This VP 0 degree, that is the reference, minus 120-degree lagging plus 120-degree leading. That. Then we have three load conductors. We have three wires for each of the three voltages or windings and a neutral wire. So depending upon the requirement, this neutral wire can either be present or absent. That gives us three-phase four-wire system or three-phase three-wire system. This is the representation of the different voltages or winding voltages starting from the alternator side to the load side. Then the phase sequence, the order in which the voltages in the three phases or coils, they reach their maximum values, that is called as the phase sequence, and it is common practice to name them after the three colors red, yellow, blue. Okay, because these are the colors of the wires which are used, so it is easy to recognize which one is connected to which phase. So here, as we all know, this is the general representation of a AC power system, starting from generator, transmission wire and load for the three-phase system. So here the alternator or generator side, it consists of three windings which have the same voltages in terms of magnitude and frequency but different phase angle. So how to connect these three phases? So there are two styles or two ways of interconnecting these three phases. First is the star or Y method of connection. Second one is the mesh or delta method of connection. So this is the star method of connection of the three phases. So here these three rectangles that you see, these are the three windings for R, that is red, Y for yellow, B for blue. Okay, so in some books you will find this in terms of coils, but here there are actually appropriate combinations of resistor, inductor, capacitor, mostly inductance, but since other parameters also come into play, I have represented in terms of this windings in terms of rectangles. So each represents a particular phase starting from the alternator to the load side, red, yellow, blue, and the point where these three windings are connected, the common point, the wire taken from that is called as the neutral line. Okay, this is the neutral line. Now here the thing that you need to understand first is these voltages ERN, EYN, EBN, which is the voltage between a particular line and neutral. The voltage between a particular line and neutral. This is ERN. This one from Y to N. Okay, from Y to N. This is EYN and this is EBN, between the particular line and neutral. So this ERN is the voltage between the red phase, the red winding and neutral. EYN is the voltage between the Y winding and neutral, and EBN is the voltage between the blue winding and neutral. So each represents a particular line, red, yellow, blue line. So in general, the voltage between a particular line and neutral point or neutral line, that is called as the phase voltages. So these are the phase voltages. Okay, these are the phase voltages, ERN, EYN and EBN for star connected system. The voltage between any particular winding or line and neutral, that is called as the phase voltages. Next is this. Here you see I have deliberately removed the neutral line. Okay, again, if we exclude or omit the neutral line, we are left with the red line, red winding line, the yellow winding line and the blue winding line. Now here this represents the voltage between red line and yellow line, red line and yellow line. This is the voltage between these two, red line and yellow line, VRY. This here represents the voltage between the yellow line and the blue line. This here represents the voltage between yellow line and blue line, VYB. And here this represents the voltage between the blue line and red line, VBR. So VRY is VR minus, means with respect to the neutral voltages, VRY is ERN minus EYN, where R is the leading one. VYB is EYN minus EBN, where Y is the leading one, and VBR is EB minus EN, where B or the blue winding, that is the leading one. So B comes first here, here Y comes first, here comes red, with the difference between their respective phase voltages. So here the voltage between any two particular lines, the voltage between any two particular lines in a star connected system, that is called as a line voltage. This is called as a line voltage, the voltage between any two lines. So here VRY, VYB and VBR, these are the line voltages. Another important thing here, VRY, it should always be in this order, VRY. If we take the opposite order, it will become negative, minus VR. Same goes for this, VYB becomes minus VBY, VBR becomes minus VRB, because these are these line voltages, they are the difference between the respective phase voltages. Okay, this. Okay, this. So they should always be taken in this sequence, RY, YB, BR, RY, YB, BR, in that particular sequence. So this is where the concept of phase sequence comes into play, RY, YB, BR, like that. Okay, so this is the phase voltage between a particular line and neutral, and this is the line voltage, the voltage between any two lines. Next, the currents. So for this star connected system, the currents in the respective phase windings R, Y, B, they are called as the phase currents. Here if you see, this is IR subscript P, this is IB subscript P, this is IY subscript P. These are the phase currents. Okay, IR subscript P, IY subscript P and IB subscript P. The phase currents in the red, Y and blue windings. These are the phase currents. Next is the currents in the respective lines. IRL, IYL and IBL. These are the line currents. Now here if you see in the star connected system, the phase currents and line currents, they are in series with respect to each other. So the phase current and line current, they are the same only for star connected system, and the current flowing in the neutral, that is called as the neutral line current IL. This. So for star connected system, the the line current and the phase current, they are the same, and for the line voltage and phase voltage, this is the relationship. The line voltage VL is equal to √3 times the phase voltage EP. Okay, this is EP is the phase voltage. So any particular line voltage, that will be equal to √3 times the respective phase voltage. But for any line or phase, the line current and phase current, they are the same. This is only applicable for star or Y connection. Okay. Next is mesh or delta connection. So here in this mesh or delta connection, the dissimilar ends from start to finish of the three-phase sequence, they are actually interconnected, joined together to form a closed loop, a closed mesh. Okay, if you compare this here, I have already discussed you about star and delta connection system in the basic concepts, you can refer to that. Same thing, star and the same 3 points are there, only they are rearranged in different forms to get the star connection and the delta connection. So here there are the 3 points R, Y, B, R for red, Y for yellow, B for blue. There are the 3 windings, okay, one connecting R and Y, one connecting R and B, one connecting Y and B. And if you see the respective phase voltages, they are here in terms of this. ERY is ER minus EY, the voltage between R and Y. EBR, the voltage between blue winding and red winding, and EYB, the difference between the yellow winding voltage and the blue winding voltage. So if you see, this is very much similar to the here, this one, the voltage between the respective lines, the voltage between respective lines, it is similar to that. So another interesting thing for mesh or delta connection system, here if you see, the line is taken from the R point, this is the red line, this Y line is taken from the Y point, so this is the yellow line, and this line is taken from the blue point, so this is the blue line. Okay, let me highlight it here. This is the red line, this is the yellow line, okay, and this is the blue line. Okay, this. So here, these are the definition of line voltage is the voltage between any two lines. So this is the difference between red and yellow, VRY. This is the difference between yellow and blue, and this is the difference between blue and red. Here also if we see, for each phase winding, the phase voltage is same as the line voltage. So here the phase connecting R and Y, the voltage is RY, the voltage between R point and Y point. So here ERY is equal to VRY, then EBR is equal to VBR, because the voltage between the same 2 points are considered, okay, this one and this one, and then EYB is equal to VYB, because the voltage between the same 2 points are considered, this point, and here also the same 2 points. So here for mesh or delta connection, the important concept here is that the line voltage is equal to the phase voltage. Like in star connection, the line current and phase current, they are the same. In delta connection, the line voltage and phase voltage, they are the same. Then for the currents, so here the currents are notified like this, they are represented like this. IR is the current flowing towards the red point, IB is the current flowing towards the blue point, IY is the current flowing towards the Y point. So these are the respective phase currents. Okay, these are the respective phase currents, IR, IY and IB. Okay, these are the phase currents flowing towards the respective points. And these are the lines that are taken. The point 1 which is taken from the red point, point 2 which is taken from the yellow point, and point 3 which is taken from the blue point. And these are the respective line currents, I1, I2 and I3. They are the line currents. And their relationship are I1 is equal to IR minus IB, I2 is equal to IY minus IR, I3 is equal to IB minus IY. Simple application of Kirchhoff's current law at each node, R, Y, B node. KCL application at R, Y and B nodes will get the respective line currents, I1, I2 and I3 in terms of the respective phase currents IR, IY and IB. So this is the representation of the line currents, okay, the line currents I1, I2 and I3 in terms of the difference of the phase currents IR, IY and IB. Okay, this. And here the line current is equal to root 3 times the phase current. So these derivations will do, but here just I am giving the basic concepts, okay, the derivations will do. So always remember, for delta or mesh connected system, line current is equal to root 3 times the phase current and line voltage is equal to the phase voltage. And for star connected system, line voltage is equal to root 3 times the phase voltage and line current is equal to the phase current. Okay, then is a balanced supply system. So this is a very important concept again. Like I said, if for a AC power system, the 3 voltages, whether it is phase voltage or line voltage, they are equal in magnitude and frequency but displaced by 120 degree. So for a 3-phase system with respect to each other, which is the commonly used system, then it is called as a balanced supply system. The other requirements are, it should have balanced 3-phase single loads, whether it is from the alternator side or to the load side. The load should also be balanced and 3-phase for each of the particular voltages. And then another thing is, it should have equal active and reactive power flow in each phase. We have already discussed about active power and reactive power, true power, reactive power, apparent power. So the true power, the cos phi component, that is called as the active component, and the sine component, that is called as the reactive component. So it should have equal active and reactive power flow in each phase. So these are the requirements for a balanced supply system. So here we have discussed about the various methods of interconnection of the 3 phases for the 3-phase supply system, which is commonly used, consisting of 3 voltages of equal magnitude and frequency but different phase angles, phase difference, generally 120 degree leading and lagging with respect to the reference, 3 loads, 3 wires for each of the voltage sources and a neutral wire, and this neutral wire is absent in the delta system. In the star system it is present, but in the delta system it is absent. So it can be either 3-phase 4-wire system, taking into consideration the star method of connection, or 3-phase 3-wire system if we take the delta method into consideration. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.